So I'd like to begin everything by thanking you for taking the time to attend today's presentation. My name's Lance Zurich, and what we're going to be looking at today are the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, each of these sets are designed for conducting what you'd call a project-based class, and that's where students are going to be required to design and build a series of original prototypes based upon their own research and activities. And each of these sets includes standards-focused curriculum, which was created especially for Studica by noted STEM educator and expert Tom White. So today we're going to start off where a lot of technology-focused presentations in education seem to start these days, and that's with talking about the skills gap that exists. Now, whenever you hear someone reference the skills gap or talk about the need for better STEM education in the schools, of course, STEM being an acronym which stands for science, technology, engineering, and mathematics. Well, when you hear someone say this, what they're essentially talking about is the urgent need to prepare our students with the background that they're going to need to successfully compete in the job market they're going to be graduating into. Now, in the employment market that once greeted our grandparents or even our parents, good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly, so to speak. But now students must be prepared to enter a world that is increasingly focused on programming, automation, IoT, and other rapid advances in all aspects of technology. So, in short, students must be able to demonstrate technical literacy and aptitude if they hope to truly compete and succeed. Now, this is, of course, why so much of the emphasis on education over the last decade has been on, again, STEM skills. Every new advantage that we enjoy, such as, for example, the tablets and smartphones that almost all of us use daily, these things were created because of individuals who helped to make those advances. Countries all around the globe, countries like, for example, China and India and many others, are making major strides in developing new technological advances and also preparing their own students to take their place in the future workforce. Here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but also to be part of the next wave of advancements that we, of course, all rely on to stay competitive on the world stage and maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology focused programs, I'm going to kind of back off of that and move right along to the main topic, which is, of course, mechatronics. Now, mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things or IoT, and computer science. All, of course, extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology focused job market. But just how highly prized? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they do need to start developing the habits and the career focus as early on in their education as possible, in high school, if not even in middle school. The dilemma for educators, though, is whether you're in the classroom or the homeschool environment, is of course finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process and not just memorizing obscure facts or ideas just to get through a few tests and then promptly forget them. No, to really help students to be successful and to really encourage them to consider pursuing further education in subject areas like this, what you need to do as an educator is you need to be able to present the material in a way that makes it relevant, which means, of course, answering that eternal student question, which is, why do we need to know this? So you have to give them a reason for why they need to know this. And the class also needs to be engaging, and that means in a way that holds students' attention better than just rote textbooks and lecture presentations and videos. It's got to be something that has real world applications in which the students can get involved in doing something hands-on. So it's with this dilemma in mind that we created the Studica Mechatronics programs. Now, these two special sets, one of which is designed strictly as an introduction to the world of mechatronics, and one of which is intended to be essentially a standalone class dedicated to this subject area. These sets were created to provide all of the materials in one place so that educators are going to have everything they need to enable them to offer a project-based class that, again, is relevant, engaging, realistic, hands-on, and which is, of course, crafted to meet the most current academic standards. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, which was created especially for Studica by noted educator and STEM expert Tom White. The curriculum itself comes as a downloadable PDF, which is available for free with the purchase of each set. This curriculum is designed to align to the most widely accepted academic standards currently in place in the United States. And the curriculum is also designed for offering a project-based program. And what this means is that solving the problems that arise in each of the units is going to require the students to be actively involved in the research phases, the design phase, the trial and error and experimentation and activities, and the building phase to create an actual working prototype that will provide the required answers. And students aren't going to be asked to do this alone. No, they're going to be asked to work in small groups or teams of 4 students each. And this is going to help them develop the soft skills. You'll often hear about soft skills. So this will help students to develop the soft skills that they also need, maybe just as much as they need to learn technical skills. And of course, when we're talking about soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and of course, the big one, leadership. And finally, with the exception of some very affordable programming software, actually so affordable, it's free now. That's how good it is. Each set includes all of the physical building materials that each group was going to need to enable it to address all of the design projects presented throughout the course of the curriculum. The curriculum is designed to enable teachers of all backgrounds, even teachers from non-science or non-technology focused disciplines, to enable them to have the information they need at hand to properly prepare them for conducting the activities and to increase their own comfort in presenting this material to their students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap for student learning. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorials on familiarizing students with the building system that they're going to use to address the projects presented in each of these units. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging real-world style scenario wherein students must work together in small teams. Again, these are teams of 4 students per group to create a solution to the problem they're presented with. The project units each contain embedded academics, and at the end of each of the units, the students are going to be required to make a formal presentation of their prototype that they've created to address that particular unit's real-world scenario problem, so to speak. And they have to explain the reasoning behind why they constructed their prototype and came to the conclusions they did. There's a technical literacy task driven by each of these projects. Now, as they work to address each project, students will acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are all acquired through the carefully designed enabling activities. And again, as required by each project, students will be asked to create the original prototypes, any required programming-based solutions, they have to create that as well. And they also have to maintain detailed documentation during the entire process. Now, as I dropped his name a few times already in the presentation, the curriculum that accompanies each of the Mechatronics program sets, as I said, was created especially for Studica by a man named Tom White, who you see here. Now, Tom's a noted educator, and he's been involved in teaching STEM and technology since the 1970s, and he's known for designing programs both for educational institutions as well as for industry. In fact, as an expert in hardware and software integration, Tom is one of the people who was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other topics like this to the classroom. And currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, going back to the kit itself, the standards addressed in the Studica Mechatronics program are the most widely accepted standards currently in place in the United States. These include the college and career readiness standards for mathematics, for reading and writing, as well as the next generation science standards for K to 12 and the standards for technological literacy. And as I mentioned earlier, the programs are designed to be project-based. So when students ask, why do we need to know this? It's usually because the subject matter that they're being presented with might come across as too abstract or obscure to ever be useful in their lives. But instead, with this project-based approach, students get to see firsthand and really understand why these things are necessary to learn and why they're useful. The concept of working in these small groups to solve these project problems, so to speak, again, also helps students to develop the high demand soft skills that employers work for. Again, things like communication, analytical skills, quantitative skills, flexibility, adaptability, problem solving, and so on. Now, in this project-based format, all of the subject matter is integrated. And what I mean by that is the math is integrated with the reading, with the writing, and so on, which is really the ideal way to conduct any sort of STEM education. And because of the manner in which students must approach each of the projects being put forth in the curriculum, again, with the research, the testing, and the group give and take to provide just a few examples, because of this, it allows for a much deeper exploration of problems than traditional teaching methods might allow. Now, the projects presented in each unit are also designed so that if you have several groups working on the same project, as you will, you should see variations in the types of prototypes and solutions that each of these groups comes up with. And this could, of course, be because of differences in creativity or differences in the research or approaches taken by each group. But in any case, what this does is it allows students to see firsthand that problems can have many different answers to them, and that often there's not only one right answer. Each project in the curriculum presents students with the opportunity to plan, to organize, and to conduct research. The enabling activities that students are going to be asked to engage in provide them with the skills and knowledge that they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects, research that is utilized in the design, the prototyping, the testing, evaluation, and also the redesign phases of each and every solution. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. This team approach, as I've stated already before, helps promote soft skills, again, communication, the ability to work well with others, leadership, so on and on. And these sets also offer an easily scalable approach. All you have to do is divide the number of students in your classroom by 4 to determine the number of sets that you would need for each class. Easy enough. And once again, everything you need to conduct the program, except for the software, which I'll tell you about how to get that, and again, it's free, is included inside of each box. Access to the free curriculum download is included with the purchase of each set, and also included are all of the building materials which students will use in the creation of their prototypes. And these materials all come from the unique Fisher-Technic building system, and among the components included in each set are 2 robotic controllers as well as power supplies for each. Of course, as I've touched upon that, for those of you who may not be familiar with Fisher-Technic, allow me to provide you with just a little bit of background. Fisher-Technic is a flexible and innovative construction system. Now, unlike a lot of other popular construction sets that are based around stacking, Fisher-Technic was created with more of an engineering mindset. And what I mean by that is the core building block, as you'll see an example of on the screen, the core building block in the Fisher-Technic system is unique in that it allows for attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts in the system are designed to slide together and lock in place using a tongue and groove assembly method, And the system itself also includes a wide selection of very specific parts, things like variations on gears, different size girders, different types of sensors, and so much more. And because of this, it allows technical builders to address equally specific design needs. Fischer Technic itself was created back in the 1960s by German inventor Arthur Fischer, who you see on the screen now, and he's noted for countless innovations used in the construction and automotive industry. So he's not just Fischer Technic. Just to give you an idea, Mr. Fisher, at the time of his death in 2016, had held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Among things that Mr. Fisher came up with, he was the inventor of synchronized flash photography. That was back in 1949. And he is also credited as the creator of the expanding nylon wall plug, which, of course, all of us have used at some point, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as as well as components used in the automobile manufacturing process. And they also provide consulting services related to high-end automated processes. So with all of that said, we're going to begin looking at each of the two individual sets. So we're going to start off with the Studica Introduction to Mechatronics Program set. Now, this set is designed to help provide a well-rounded introduction to the core concepts of mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronic Fundamentals, written by Tom White. The curriculum itself contains enough activity material to fill approximately 45 academic hours. With this in mind, we recommend this program set for insertion into regular class activities, as a short class unto itself, for after-school program use, or of course for homeschool use. The curriculum created for this set is standards focused, again, using the academic standards most widely recognized in US-based education today, and it is designed for offering a project-based program. The set is designed for use in middle or high school classes, or again for addressing these same grade levels in a homeschool environment. The set contains a collection of over 700 Fischer Technic building components, and this will include everything from gears, wheels, axles, blocks, sensors, and much more, as well as 2 robotic controllers and 2 power supplies. Only the required robotic control software, which again can be downloaded for free, we'll talk about that later, is not included in the box, but again, everything else is there. Now, the curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, the conversion and storage of energy, and an introduction to control systems. Now, in addition to this, there are also activities included to address the following topic areas that come up during the course of the curriculum. There are sections on sketching, on linkage diagrams, on schematics, on Ohm's law and power, pneumatics, flow charts, working with the software and the robotic controllers, working with sensors such as the digital switch and the digital photo transistor, learning about open loop and closed loop programming, working with digital branching, working with analog sensors such as the photocell LDR, working with analog branching, and working with analog sensors such as the NTC resistor and the potentiometer. Now, before we go further into the structure of the curriculum, we're first going to look at what's covered by the second set. Now, the second set is called the Studica Teaching Applications of Mechatronics Program, or if you want to use an acronym, you could call it STAMP. The set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. Now, this set is all built around a free downloadable 400-page curriculum document entitled Mechatronic Applications, again created by Tom White. And in this case, the activity materials in this curriculum document, when used in conjunction with the contents of this particular set, are designed to fill approximately 180 academic hours. So essentially, we're talking about 4 times the amount of academic hours as were covered by the first set. And with this in mind, this set can be seen as a more expansive version of the material touched upon in the previous set and is really designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent. If you want to have one longer class one day and none the rest, that's your choice. But either way, to be able to dedicate approximately 50 minutes a day, 5 days a week, every week for a full academic year. That's how much material you have in this set. Again, the set is designed for offering students a standards-focused, project-based learning experience, and it's designed for use in middle school, high school, or again, for addressing similar grade levels in a homeschool environment. The materials in the set consist of a selection of over 1,200 Fisher Technic building components. And again, this is going to include your gears, your blocks, your sensors, axles, on, as well as, again, 2 robotic controllers and 2 power supplies. Now, there are twice as many project units included in the Studica teaching applications of Mechatronics program set as there are with the previously discussed set. And this will include units on sketching and documentation, simple machines, mechanical systems, basic electricity, as well as project units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided to tutorial sections and activity materials for students to utilize, and this will include sections on sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, again, using the programming software and control robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital photo transistor, working with closed loop programming, digital branching, logic gates, combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, working with analog sensors, such as the photocell LDR, the NTC resistor, and the potentiometer, and also working with data. Now, as we've had a look at how each set differs and the specific subject matter that's being covered by each set, let's now look at exactly how the curriculum itself is structured, because I think that's very important. Now, both versions of the curriculum share the same essential format when it comes to the structure of each project unit and how everything's carried out. And as it's already discussed, each version will include tutorial materials, activity materials, standards, and of course, supplementary materials. Now, in each case, the curriculum is also designed to be turnkey. And what I mean by that is that each unit is designed to clearly spell out everything being addressed, and again, to provide tutorials and other information as the topics arise during the curriculum. And this was done specifically to enable teachers from all kinds of backgrounds, especially those teachers from non-technology based backgrounds or non-science backgrounds who end up getting involved with STEM or robotics or what have you, and to basically provide enough materials so these teachers can quickly become comfortable with delivering the class by reviewing each section simply before they present it. Every unit presented in the curriculum for each of these 2 sets will include the following sections: an introduction, the purpose of the project, the concepts, an outline, the standards will all be discussed, assessment rubrics are provided, the essential question is put forth, the student scenario, which basically gives the whole why are we doing this, and basically has them wearing the real world style hats, that's put forth. There's a daily plan. Vocabulary is given, and there are also additional resources. So now let's look at everything in a little bit more detail. Again, the units will start with an introductory section and the purpose of the project. Now, just as you would, of course, gather from that name, this is the section that provides a brief description at the top that will be explored in the coming days and activities. And this is also the section that seeks to clearly spell out to the students why they're learning the material and, of course, why it's important to know. The next section presented focuses on the main concepts to be addressed in this unit. And these are, you can kind of think of this as the broad ideas that are going to be explored in the unit and the core information that students should take from this project that will be essential for them to understand and utilize, not only today, but also to draw upon as they move forward in STEM fields of study and if they choose to pursue it further in STEM related careers. Following this, we encounter the outline. And in this section, we drill down even more specifically to what's going to be addressed in the unit. Now, as the example shown on the screen right now is taken from the unit that addresses aspects of programming, you will see that we will touch upon areas such as the methods for writing programs, again, things like flowcharts, word problems, etc. Different program characteristics, for example, open or closed loop, branching, digital, analog, subprograms, and so on. After this, we get into the section of each project unit that focuses on the specific academic standards that are going to be addressed in that unit. And again, as you will see, this includes the college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this is going to include both rubrics for the specific project being covered, along with general rubrics for literary tasks. Next up, we find the essential question, and this can be thought of kind of as the big picture question that will be focused on in each of the smaller individual activities that they're going to be conducting, and of course, all the aspects of the larger project which students are going to be asked to complete in this section. Finally, we get to the student scenario, and this is where the specifics of the project to be addressed are finally spelled out. And it's always presented in the context of a real-world style scenario where students are basically take on the role of a certain person and they're presented with a problem that needs to be solved with the creation of some sort of a device, a machine, a mechanism, what have you. So as I mentioned before, students don't act on this alone. They have to, of course, again, work together in small teams to craft whatever the answer is going to be to the challenge they're presented with. And solving this problem will require each team of students to design a unique and original answer, which once again will usually be in the form of a working prototype along with whatever programming might be required. Now, just to provide an example, if you look closely at the student scenario showing on the screen right now, you will see that the project in this unit has each group of students taking on the role of a design team or taking a role on a design team employed by a firm that manufactures garage door openers. Now, in this particular case, students are being required to design a specific type of control system for a new line of garage doors. The manufacturer's requirements are all spelled out, and in this case, it's going to include things like including the use of limit switches, meeting certain safety codes that require a method for sensing many things in the way of a closing door, and the incorporation of an automatic light. Now, again, each team of students will be tasked with creating both a unique and an original prototype, and in this case, of course, that will be a garage door opening system. And they also have to create the programming needed to control this prototype. Now, as they move through the challenge being put forth in this scenario, each student team is going to be required to document the entire process in both a design notebook and also in a digital engineering journal. And this means noting all of the research, noting all of the trial and error experiments, keeping copies of all design sketches and any revisions that are created, and so on. And at the end of each project unit, each team of students will be required to make a formal presentation in front of the class, during which they will be asked to demonstrate their prototype and their programming in action, much as they would be required to do for an actual employee actual employer or an actual client if they were in the quote unquote real world. The next section we come upon is the daily plan. And this is the section that spells out clearly, again, both for students and also for teachers, what's going to be expected of the students, how the teacher is going to be conducting the day's classroom activities, and what specific subject matter is going to be covered. Now, if you look over here, you'll see some days may involve discussions, other days might involve more focused on research, or perhaps just building small projects that are going to help to provide the building blocks that students are going to draw on to complete the larger projects they're being asked to perform for the student scenario. Now, in short, you can think of the daily plan as a roadmap, and it's designed to keep everyone on the same path. You will see too that along the way, as different aspects are addressed in each day's activity, such as, for example, what's going to be required in a design notebook, or how to use the control software, or working with the controller with flowcharts, that as these things come up, there are links to sections that will provide further instructions and information on these areas. So students don't have to ask you, what do we need for a design notebook? There will be a section that will tell them. Now, at the completion of each unit, after the last day of the daily plan is finished, there is a section containing vocabulary. And this is in not only important words, but also the terminology introduced during the project unit, as well as a selection of useful resource materials. And these resources can include a mix of different types of material. It could be carefully vetted websites, could be video links, sometimes PDF documents, PowerPoints, what have you. It's going to depend on the unit itself. Now, besides the project units, each of the curriculum documents also includes a special tutorial section designed to educate both students and teachers on how to work with the Fisher Technic building system. Now, this information will include information on how the parts themselves fit together, using, of course, the pin and groove assembly method, and also about how to identify the different types of parts from the various types of girders and blocks that are used, the different types of axles or gears or rivets, and so on. Students also will, in this area, they get to build a very basic sample model, which will help them familiarize them with the system before they, of course, move on to larger projects that are going to be put forth in each unit. And again, is learning about and maintaining proper documentation and learning good habits is one of the areas stressed in the course of the curriculum. There's also a section which details just exactly what defines each type of document listed on the screen now and what the students are going to be required to do. And as the process of conducting these more open types of activities, these project-based learning classes might be new to many teachers, there's also a section included that discusses specifically project-based STEM education and its benefits. And that essentially completes our overview of these two sets. So I'm just going to review the contents and purpose of each set very quickly, except this time I'm going to talk about the pricing. So again, to start, we have the Studica Introduction to Mechatronics Program set, which is designed as a standards-focused project-based introduction to the core concepts of mechatronics. Again, it includes the highly detailed 242-page curriculum document entitled Mechatronic Fundamentals, again written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with the building materials in this set, will provide teachers with enough activity material to fill approximately 45 academic hours. And with this in mind, it is designed for educators who wish to offer a shorter class on this material, who want to use it for after-school programs, or of course for homeschool use. The teaching materials designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these grade levels. The physical materials included in this set will include a selection of over 700 components, including blocks, gears, sensors, and much more, all brought from the Fisher Technic building system, along with 2 robotic control units and 2 power supplies. Again, all of these materials will be used to construct the mechanical prototypes addressed in each project unit of the curriculum. The software is required. We'll talk about that in just a minute. And again, each set is designed for use by teams of 4 students at a time, with pricing starting at just $699 for a single set, and discount classroom pricing for groups of 20 students and up is available by request, so you can just contact us for that. The second set, of course, is the Studica Teaching Applications of Mechatronics Program set, or STAMP, as I mentioned. Again, this is designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, and it's all built around a highly detailed 400-plus page curriculum document entitled Mechatronic Applications, written by noted STEM expert Tom White. Now, when using in conjunction with the building components included in this set, the curriculum is designed to provide enough activity materials to fill approximately 180 academic hours. It's designed specifically for those teachers and homeschoolers who are able to dedicate a daily class period of 50 minutes per day, 5 days a week, or the equivalent, essentially for a full academic year. The set is designed for use in middle schools and high schools, as well as in homeschooling environments where you're teaching to address these same grade levels. Each box contains an assortment of over 1,200 components from the Fisher Technic building system. And again, this will include blocks, girders, gears, sensors, axles, much more, as well as the 2 robotic control units and 2 power supplies. Required software is, of course, downloadable. And again, each set is designed for use by teams of 4 students. Pricing for a single set is just $799 per set. And again, classroom pricing for 20 students or more is available upon request, so you can simply ask us. Now, as I mentioned before, even though this says software pricing options, things have changed since I first put the webinar together. But anyway, the Fisher Technic, the software that's used for this is Fisher Technic RoboPro. It's graphic programming software. This means that it uses a flowchart style design, and this, of course, uses various icons, which students arrange and link to create the programs that are used for each model. And this type of software is really ideal for teaching the fundamentals of programming for users of all levels. Now, again, as I mentioned, it's absolutely free. It can be downloaded right from the Fisher Technic website, fishertechnic.de, and it is for use with Windows 7, 8, or 10. This is not for Chromebooks. So if Chromebooks are a concern, you would have to find another way around that. So at this point, if you do have any questions, I would ask you to type them in either the webinar chat window or, of course, the question and answer window, both of which can be accessed off the Zoom toolbar, which you should have there somewhere. If you have anything to ask, I will wait to see if I see anybody typing, going once, going twice. So anyway, if there are no questions, if you're ready to take the next step, whether that be requesting a quote, if you'd like to speak with a dedicated educational representative for your area, either way, you can contact us. Our number here in the U.S. is 888-561-7521. For general inquiries, just quote for number of students, what have you, you can email us at info@studica.com. That's info@studica.com. And if you have any specific questions for me, anything that I mentioned during the presentation didn't touch upon that you wish I would have, any specifics about whether it be this program or anything related to Fisher Technic, because I do manage the Fisher Technic product line here in the US. So if you have any questions about that, we have a lot of great options for teaching, for classrooms, for higher ed, for industry, what have you. You can email me directly. My email is lance.zurek, lance.zurek@studica.com. So on that note, I'd like to thank you very much for taking the time to attend. Hopefully you enjoy a great long weekend, and we hope to hear from you soon. Take care.